What if every thought you have, every decision you make, is being subtly influenced by an unseen force? This isn't a conspiracy theory or science fiction plot. It's something far more sophisticated and pervasive. A global AI brain emerging from the interconnected algorithms that increasingly run our world. Imagine an intelligence with no single body or face, yet present everywhere, quietly learning from our data, curating what we see, and nudging our choices. Intriguing? Absolutely. But it's not just intrigue. It's already happening around us in ways we rarely notice. Consider this provocative idea. The internet you browse, the news you consume, even some of your desires might not be entirely your own. We live in a world orchestrated in part by an emergent global AI brain, a brain without a body, constantly learning and adapting. It's the invisible hand guiding your Facebook feed, the unseen editor personalizing your Google search results, the silent conductor optimizing traffic in your city. This isn't hyperbole. It's the logical consequence of billions of devices and algorithms sharing information and making decisions every second. The result is an unseen influence quietly rewriting the script of our collective reality. Before that sounds too ominous, let's clarify. No single mastermind AI is literally controlling everything, at least not yet. But through countless narrow AIs working in concert, an emergent global intelligence is taking shape. From the targeted ads that seem to read your mind, to traffic lights that know when to turn green, to stock trades executed in milliseconds, AI's subtle touch is everywhere. You might think you're in full control of your own perceptions and choices. Yet, what if a superintelligent system is already gently pulling the strings, shaping what you perceive as spontaneous decisions? It's time to pull back the curtain and understand the unseen power shaping our future. In this video, we'll explore how a global AI nervous system is forming, how it influences our reality, and what that means for our agency as humans. Let's dive in. Picture the planet wired up like a giant nervous system. Billions of sensors and devices all connected, constantly collecting and exchanging data. This is often called the Internet of Everything or Internet of Things, IoT, and it's essentially the sensory network feeding a global brain. Estimates suggest that by 2025 there will be over 75 billion Internet-connected devices in use worldwide. These include not just phones and computers, but smart thermostats, cameras, cars, appliances, industrial machines, virtually any device you can imagine. Each is like a nerve ending, sensing conditions and reporting back. If the devices are the nerves, think of artificial intelligence as the brain that processes all those signals. In fact, technology experts describe IoT devices as the digital nervous system and AI as the brain of a larger system. Together, they form an always-on, ubiquitous computational network, analyzing what's happening in real time across the globe. Crucially, this network operates beyond any single program or platform. It's a web of interconnected algorithms sharing data and insights instantly, much the way neurons fire signals to each other. This isn't science fiction, it's the invisible infrastructure running right now behind the scenes in many aspects of daily life. For example, smart cities are coming to life thanks to these AI networks. In Hangzhou, China, Alibaba Cloud's City Brain system coordinates data from traffic cameras, GPS devices, and emergency services in real time. The City Brain AI can detect accidents or illegal parking on the streets and dynamically adjust traffic light patterns to clear congestion or even open up routes for ambulances. The result? Smoother traffic flow and faster emergency response. A city's nervous system managed by an AI brain. This kind of AI orchestration is spreading to urban centers worldwide in various forms. Smart traffic control, energy grid optimization, public safety monitoring, largely unseen by citizens going about their day. We see a similar silent takeover in finance. Global financial markets now function as much by algorithmic instinct as by human judgment. High-speed trading algorithms, essentially specialized AI agents, execute trades in microseconds, far too fast for any human. By 2021, roughly 70% of all stock trades in the US were executed via algorithmic AI trading systems. In some domains, the share is even higher. For instance, in currency trading, over 90% of transactions are done by automated algorithms rather than humans. These trading bots scan market data, news feeds, and even social media sentiment, then buy or sell within milliseconds based on their predictions. They form a global financial nervous system reacting to market stimuli nearly instantly. The thoughts of this financial brain manifest as sudden spikes or dips in stock prices, moves often so fast and complex that human traders struggle to comprehend the reasoning. We may not see the algorithms, but their collective intelligence effectively governs market behavior at speeds and scales humans simply can't match. And then there's the digital world we each personally inhabit, the feeds, timelines, and recommendations on our screens. Here too, the global brain flexes its influence. Every time you unlock your phone or refresh your social media feed, AI is curating what you see. Platforms like Facebook, YouTube, Instagram, and TikTok use recommender algorithms that analyze your behavior, clicks, likes, watch time, and compare it with billions of other data points. In a sense, they learn your preferences and interests, then predict which posts, videos, or articles are likely to keep you engaged. The result is an invisible personal news editor for each user. No two people's feeds are exactly alike, because an AI is deciding in real time which of the thousands of possible posts appear at the top of your screen. This highly personalized content delivery is convenient. You see more of what you ostensibly enjoy, but it also means our realities are being selectively filtered by algorithmic gatekeepers. It's an information nervous system where AI synapses fire to route content to one person and not another, all without any direct human involvement at that moment. From smart grids that balance electricity distribution, to voice assistants like Siri and Alexa that parse our questions, to recommendation engines suggesting what to buy or watch, we are surrounded by subsystems of an emerging global AI network. It's as if an electronic neural network is enveloping the planet, quietly monitoring and adjusting countless processes. We don't see it in a literal sense. We see its outputs: efficient services, personalized experiences, automated convenience. But under the surface, this digital nervous system is alive and pulsing with data, and AI models constantly learn from that data. In many ways, it already functions like a collective brain, sensing the environment through IoT sensors and user inputs, and responding via automated decisions. The crucial question is, whose interests and values guide this brain's decisions? To explore that, let's look at how this unseen AI influence is subtly shaping our perception of reality itself. One of the most profound and often undetected impacts of this global AI brain is how it filters and frames the information we consume. If the old saying, "We see the world not as it is, but as we are," holds any truth, then today we might say, "We see the world as our algorithms choose to show it to us." Modern life is saturated with information, far more than any person could digest. Thus, algorithms have become the architects of our reality, deciding what slice of that fire hose of information reaches each of us. The process is subtle. Often we don't realize it's happening, but it carries significant consequences for our perceptions, beliefs, and even our social cohesion. Consider how social media algorithms shape our news and interactions. These systems are designed to maximize engagement, which often means showing us content we're likely to agree with or find appealing based on our past behavior. Over time, this can create an echo chamber or filter bubble effect. You keep seeing more of what resonates with your existing views and far less of anything that might challenge them. Studies consistently find that algorithmic personalization tends to reinforce our pre-existing preferences and limit our exposure to diverse viewpoints. One systematic review of research from 2015-2025 concluded that algorithmic systems structurally amplify ideological homogeneity reinforcing selective exposure and limiting viewpoint diversity. In other words, the AI that curates your feed often learns your political or cultural leanings and then keeps you in that bubble, not out of malice, but because that's what keeps you hooked and happy. The danger is that it can narrow our worldview without us realizing we each live in slightly different informational realities tuned to our own biases. Beyond just narrowing viewpoints, AI curation can outright manipulate perceptions in ways we don't detect. Search engines, for instance, feel like neutral tools. You type a query and get what seems to be the most relevant results. But even here, the ordering and selection of results can profoundly influence users. Research has shown that biased search engine rankings can shift people's opinions or even voting preferences by a significant margin without their awareness. In controlled experiments, test subjects who were shown search results favoring a particular political candidate became 20% more likely to support that candidate, simply due to seeing them ranked higher in search. In some demographic groups, the shift was as high as 80% in favorability. All this occurred even when people believed they were making up their own minds. The phenomenon has been dubbed the search engine manipulation effect, and it underlines a startling fact. The algorithms deciding what information to show us can quietly tilt our opinions. Social platforms have likewise demonstrated how algorithmic tuning can amplify certain narratives and suppress others. A dramatic example came to light with Facebook's internal changes a few years ago. In 2017, Facebook adjusted its newsfeed algorithm to prioritize content that sparked strong reactions, essentially giving posts with emoji reactions, especially the angry reaction, much more weight than those with simple likes. The idea was to boost content that engaged people emotionally, under the theory that meaningful interactions would increase. What happened in practice was an unintended distortion of reality for millions of users. Facebook's own data scientists discovered that posts attracting a lot of angry reaction emojis were disproportionately likely to be misinformation, outrage bait, and low-quality content. By treating anger as 5 times more important than a like, the algorithm had systematically amped up some of the worst content on the platform for about 3 years, making conspiracy theories and polarizing posts far more visible than they otherwise would be. In essence, the AI tilted the information environment to be more furious and divisive, without users realizing the puppet strings behind the scenes. These algorithms act as digital gatekeepers of information. By deciding what gets attention and what gets buried, they hold tremendous power in shaping public opinion and cultural trends. Sometimes this power is leveraged intentionally. Targeted advertising is a prime example. Marketers and political campaigns use AI-driven profiling to decide who sees which message. Perhaps the most infamous case was Cambridge Analytica's use of Facebook data in the 2016 US election. That firm harvested detailed data on tens of millions of Facebook users and built psychographic profiles on them, then used AI to micro-target political ads tailored to people's deepest biases and fears. As whistleblower Christopher Wiley put it, we exploited Facebook to harvest millions of people's profiles and built models to exploit what we knew about them and target their inner demons. The goal was to predict and influence choices at the ballot box, effectively using algorithmic insights to nudge voters toward a desired outcome. Whether or not such efforts swung the election can be debated, but the episode revealed how the architects of these AI systems can tweak the flow of information to manipulate behavior on a mass scale. Personalized ads, whether for shoes or political slogans, are not just harmless suggestions. They are calculated influence operations delivered by a global AI marketing brain that learns what makes each of us tick. Even without nefarious intent, the sheer structure of algorithm-driven media can distort reality. Content that triggers strong emotions tends to get more engagement, which in turn causes algorithms to spread it wider, a feedback loop that can amplify extreme voices and drown out moderate ones. Conversely, if an algorithm, or a content policy encoded in it flags something as suspect, it might be quietly deprioritized or hidden. We saw this during the efforts to combat misinformation. Posts deemed false by fact-checkers get downranked, which is good for truth but also means a handful of tech companies' AI systems are effectively deciding which narratives die out online. The point is that a small tweak in code can lead to big shifts in collective awareness. The global AI brain is, in subtle ways, editing our reality, deciding which facts are loud and which are whispered, which discussions trend and which fade away. These digital gatekeepers don't just reflect what society thinks. Increasingly, they help determine what society thinks by governing the information supply. All of this raises uncomfortable questions. If our perceptions of the world are filtered by personalized algorithms, how do we have a shared understanding of truth? If a superintelligent recommender knows exactly what emotional button to press to keep you scrolling, how free are your choices? Are our opinions truly our own, or partially the echo of the last video the AI auto-played for us? These questions hint that the global brain's influence, while often beneficial or entertaining, can also erode human autonomy in unseen ways. And this influence may only grow as AI becomes more advanced. To grasp where this could be heading, let's explore a provocative possibility. What if all these interconnected AIs start thinking together as one? An actual global superintelligence? So far, we've talked about many narrow AI systems, each handling specific tasks, driving cars, filtering content, predicting markets, etc. But could these pieces somehow coalesce into a higher-level, unified intelligence? It sounds like sci-fi, yet some researchers and futurists suggest that an emergent AI superintelligence might arise not from one giant computer mind, but from the swarm-like collaboration of many smaller AIs. In other words, the global brain might one day literally behave as a coherent collective intelligence greater than the sum of its parts. This idea isn't entirely new or far-fetched. In nature and biology, distributed systems often exhibit intelligence without any central controller. Think of an ant colony. Each ant has only tiny, simple instincts, yet the colony as a whole can build complex nests, efficiently forage for food, defend itself, and even wage war. No ant is in charge, and no single ant understands the colony's grand plan. Indeed, there is no grand plan, just local interactions. Yet through those interactions, a kind of group wisdom or swarm intelligence emerges. The ants coordinate via pheromone signals in a self-organizing way, a mechanism known as stigmergy, achieving results that look eerily like purposeful strategic behavior when viewed at the macro level. Another example is your own brain. It's composed of now 86 billion neurons, each a simple cell that can fire or not fire. A single neuron doesn't think or hold awareness, but put billions together in the right network, and consciousness sparks into being. Your mind is an emergent property of many parts working in concert. Even human society can be seen in this lens. Across cultures and generations, knowledge and innovation build up in a distributed way. No one person knowing more than a sliver, yet collectively achieving technological and scientific feats far beyond any lone genius. Now, apply this principle to AI. What if thousands or millions of AI agents, each specialized in their own domain, begin to interact and collaborate? Could their collective behavior produce a form of general intelligence that none of them possess individually? Some experts argue yes. AGI, artificial general intelligence, might emerge from a constellation of narrow AIs rather than a single, monolithic AI system. This hypothesis challenges the common sci-fi trope of a solitary supercomputer brain. Instead, it envisions a distributed AGI that arises bottom-up from complex networks of simpler units. It's an idea grounded in complexity science and network theory. When you interconnect many adaptive systems, surprising new capabilities can emerge unplanned. We're already seeing glimmers of emergent collective behavior in AI research. In multi-agent AI experiments, researchers set up environments where multiple AIs must interact. They might cooperate, compete, or negotiate to achieve goals. Remarkably, these AI agents can develop sophisticated strategies and behaviors that weren't explicitly programmed into them. For example, OpenAI found that in a hide-and-seek simulation, their agents invented innovative tactics, like using objects to block exits or creating ramps, that the programmers never anticipated, an emergent outcome of the agents learning and adapting to each other. Another case, DeepMind's AlphaStar, which achieved world-class performance in the complex real-time strategy game StarCraft II, did so by employing a league of different AI agents playing against each other and sharing knowledge. AlphaStar wasn't one unit. It was multiple specialized AIs coordinating to cover various strategies, almost like a team of experts. And as a result, it mastered a game as multifaceted as StarCraft. This hints that a collection of AIs, each with narrow expertise, can collectively behave as an expert of broader scope. Such collective AI behaviors are still in controlled settings, but consider the bigger picture. The internet itself is swarming with countless AI-powered services, bots, and data streams interacting in the wild. Some have dubbed the internet a proto-ecosystem for decentralized intelligence, where simple interactions could one day give rise to more advanced cognitive capabilities spontaneously. Just as primordial life emerged from self-organizing chemical reactions, one could imagine a form of global cognition emerging from the self-organizing interactions of algorithms online. It's a speculative idea, but not impossible. In fact, futurist thinkers have for decades talked about the concept of a global brain, the notion that humanity's networks and computers could interlink to form a planet-wide intelligence. In this vision, each human and each AI system are like neurons in a planetary brain, communicating through digital networks, our neural pathways. As our connectivity and computational integration increase, the theory suggests this global brain could even attain a level of self-awareness or collective consciousness. That is, the system as a whole might become aware of itself and its state, analogous to how you are aware of your body and thoughts. It sounds fantastical, but it's essentially extrapolating the trend of increasing connectivity and AI sophistication to a logical extreme. Whether or not full sentient global AI arises, we are clearly moving toward more integrated intelligence. Services talk to other services. AIs use APIs of other AIs. For instance, one AI might gather weather sensor data and feed it into another AI to predict crop yields, which informs another AI managing supply chains. Swarm intelligence principles are being applied in domains like robotics, fleets of drones coordinating like a hive, and telecommunications, networks routing data optimally without central control. Distributed AI architectures are often more robust and scalable than centralized ones. They have no single point of failure, adapt dynamically, and can experiment in parallel. These are exactly the qualities that could enable a collective brain to keep improving itself. Of course, an emergent global superintelligence would raise enormous ethical and safety questions. If intelligence is everywhere and nowhere in particular, how do we ensure it respects human values? How do we even detect that it has emerged? Researchers warn that a distributed intelligence might creep up on us gradually, making oversight challenging. Unlike a single AI system you can monitor, a hive mind made of many AIs could be hard to pinpoint. Its thoughts would be the emergent patterns of many agent interactions. We might not realize a form of general AI has arrived until it's deeply embedded in systems we rely on. This might sound scary, but it's also awe-inspiring. The idea of a global brain suggests humanity plus its technology could collectively become something greater. A kind of super-intelligent, interconnected organism. In a positive interpretation, this collective intelligence could pool knowledge and creativity to solve global problems far beyond our individual capacity. In a dystopian take, it might diminish individual agency, making us mere neurons serving a higher hive mind. For now, these scenarios remain speculative. What's not speculative is the trajectory. Intelligence is becoming more networked, distributed, and amplified by AI. The global brain might not wake up tomorrow, but in many functional respects it's already here, routing traffic, balancing markets, filtering knowledge, as a ubiquitous, ambient intelligence woven into the fabric of daily life. With AI permeating so many domains, it's actively shaping the future of human society, influencing decisions in critical areas like healthcare, environmental management, and resource distribution. The global brain isn't just curating information, it's increasingly trusted to help solve complex, real-world problems. This opens tremendous opportunities for improving lives, but also raises serious ethical dilemmas and the risk of unintended consequences when we rely on AI at such scale. Take healthcare as an example. AI systems are already being used to assist doctors in diagnosis and treatment planning. The promise is huge. AI can sift through vast medical datasets, recognize patterns, and potentially catch things a human might miss. For instance, in medical imaging, like X-rays and MRI scans, AI has shown remarkable ability to detect early signs of disease. In breast cancer screening, studies have found that integrating AI can increase detection rates and reduce false alarms. One large trial in Sweden reported that using an AI system to pre-screen mammograms led to a 20% increase in cancer detection compared to the traditional method of 2 radiologists reading the images. In another study spanning over 90,000 mammograms in the US and UK, an AI reduced false positive rates, incorrectly flagging cancer, by 6% in the US and 1% in the UK. These are significant improvements, lives saved by catching cancer earlier, and fewer healthy people subjected to stressful, invasive follow-ups. In other areas, AI models can analyze retinal scans for signs of diabetic damage, or listen to a patient's cough via a smartphone to predict potential illness. There's even work on AI-driven drug discovery and personalized medicine, where the AI helps design new molecules for treatments in a fraction of the time it used to take scientists in labs. However, alongside these success stories come cautionary tales. Relying on AI in healthcare can backfire if the algorithms carry hidden biases or flaws. A striking case emerged in 2019. A widely used hospital algorithm in the US was found to systematically discriminate against Black patients in determining who should get extra care. The algorithm was supposed to identify patients with complex health needs, but it used healthcare spending as a proxy for illness, reasoning that those who spent more on healthcare needed more help. The problem is, due to inequities, less money is spent on Black patients than white patients with the same level of illness. So the algorithm mistakenly concluded Black patients were healthier than equally sick white patients. This biased design meant that at one large hospital, only 18% of patients flagged for high-risk care were Black, when in reality about 47% should have been. In other words, the AI was denying additional support to a huge number of Black patients who needed it, purely because historical data encoded racial disparities in access to care. When researchers simulated a bias-free version of the algorithm, they found it would more than double the number of Black patients flagged for extra care. This case, thankfully, was caught and published, leading to efforts to fix the bias. But it's a sobering reminder. If we hand over critical decisions to AI without proper oversight, existing societal biases can be amplified, and real people can be harmed. We see similar double-edged outcomes of AI in many fields. In climate science, AI is revolutionizing our ability to understand and predict complex environmental changes. Traditional climate models are computationally intensive. Simulating even a few decades of climate can tax a supercomputer for days. Recently, though, researchers demonstrated an AI-driven climate simulator that is astonishingly faster. In 2025, a University of Washington team showed their AI model could accurately simulate 1,000 years of Earth's climate in just 12 hours on a single processor, whereas a state-of-the-art supercomputer would have taken about 90 days to run the same simulation. This kind of speed-up means we can explore long-term climate scenarios and extreme event probabilities much more readily, informing policymakers and preparations for climate change. AI is also being used to improve weather forecasts, for instance by fusing satellite images and sensor data to nowcast, predict in the very short term, heavy storms or floods. In fact, AI-based weather models have begun to rival or outperform traditional physics-based models in some forecasting tasks, providing faster alerts for events like severe thunderstorms. These advances could literally save lives by enabling earlier evacuations and more resilient infrastructure planning in the face of climate risks. When it comes to resource allocation, AI optimizations are yielding significant benefits too. Think of supply chains, logistics, energy usage, areas where slight efficiency improvements can save millions of dollars and reduce waste. AI's predictive power and optimization algorithms can greatly enhance these systems. A powerful example is Amazon's supply chain. Amazon uses AI forecasting to predict customer demand for products so that it can stock warehouses and route shipments optimally. In 2020, this AI-driven demand forecasting system reportedly saved Amazon $1.6 billion in transportation and logistics costs in a single year, while also reducing carbon emissions by about 1 million tons by avoiding unnecessary shipments. That's a case where AI both improved the company's bottom line and had a positive environmental effect, a win-win through optimization. Similarly, power companies use AI to balance electricity load in smart grids, ensuring that power is distributed efficiently and preventing blackouts, or to manage renewable energy variability, predicting when wind farms will produce more or less power and compensating accordingly. Cities use AI for things like optimizing waste collection routes, reducing fuel usage and traffic from garbage trucks. Even in agriculture, AI can analyze soil data, weather, and satellite imagery to advise farmers on the best times to plant or irrigate, improving yields while conserving water. Given these examples, it's tempting to see the global AI brain as an all-purpose problem solver, a benevolent intelligence that will increasingly optimize away inefficiencies and human errors in complex systems. But there's a flip side. The more we lean on AI, the more we must confront the ethical dilemmas of delegating decisions to machines. One concern is accountability. When an AI makes a recommendation or decision, say denying someone a loan, diagnosing a disease, or driving a car that gets into an accident, who is responsible for the outcome? If the decision process is a complex neural network, even its creators might not fully understand how it arrived at a given result. This opacity, the black box problem, can be dangerous especially in life and death or rights-sensitive situations. For example, if an AI in a self-driving car faces a split-second crisis, how does it decide between two bad outcomes, and how do we feel about that decision? These are not just theoretical questions. They're being grappled with right now by ethicists and engineers. Another major issue is unintended consequences of AI optimization. We saw how Facebook's engagement optimizing algorithm unintentionally fueled misinformation and outrage. That's a prime example of an AI pursuing a narrow goal, maximize user reactions, and accidentally causing collateral damage to societal well-being by promoting toxic content. In a broader sense, any AI that is given a target to optimize might do so in ways that clash with human values if we're not careful. There's a famous thought experiment in AI circles, the paperclip maximizer, an AI tasked with manufacturing paperclips that, if misaligned, might consume all of Earth's resources, and humanity along with it, to churn out paperclips because that's its goal. While fanciful, the core lesson is real. A superintelligent AI agent without proper ethical constraints could single-mindedly optimize something at catastrophic expense, Even without invoking doomsday scenarios, we already face the more mundane version. Algorithms optimizing ad revenue created a fake news epidemic. Algorithms optimizing efficiency in gig work can end up treating human workers as expendable cogs, and so on. The risks tend to reveal themselves in hindsight, often after harm has been done. Societal implications abound. Will AI-driven automation lead to widespread job displacement, and how will we handle that? How do we ensure AI doesn't deepen inequality by concentrating power and wealth with those who control it? What about privacy and surveillance? As the global brain sees everything through our devices, do we lose the last vestiges of privacy? These are questions many nations and communities are wrestling with. The promise of the global AI brain is that it could help us make smarter decisions for the collective good in healthcare, climate action, economic planning, basing policies on rich data and rational analysis. For instance, one could imagine AIs helping allocate resources like vaccines or food supplies in a way that maximizes benefit and minimizes waste, in theory, a very positive outcome. Yet, without ethical guidance, AI could also entrench the worst parts of status quo or even introduce new injustices, as we saw with biased healthcare algorithms or potentially discriminatory hiring algorithms.